Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The structure shows both a carbon-carbon triple bond, alkyne, and a carbon-carbon double bond, alkene, making this an anion compound. Moving on to the next step. Starting from the left terminal carbon, there are 6 carbons total. C1 is equal to CH2, C2 is equal to C3, C4, C5, C6, CH3. This gives a hexane backbone, so the parent chain is hex. Moving on to the next step. The triple bond, Na, is between C4 and C5 and the double bond, Na, is between C2 and C3. Numbering from the end that gives lower locants to the double bond at C2, C3, locant 2, and triple bond at C4, C5, locant 4. The suffix becomes N4 Na, with the Na at position to giving hex-2-en-4 Na. And for the final step, at C2 substituents are H and C1, CH3 group, lower priority, versus at C3 substituents are H and C4, C5, C6 chain. Applying EZ rules, at C to the chain, C1 has higher priority than H, at C3 the alkynyl chain has higher priority than H. The two higher priority groups, C1 chain and C4 chain, are on opposite sides of the double bond, making it the trans configuration. Parent chain is equal to hex, double bond at 2 with E geometry, triple bond at 4, 2E, hex-2-en-4 Na. Therefore, the correct answer is 2E, hex-2-en-4 Na. The correct answer is shown on screen.